So this is Calculus AB Unit 7 review. So question number 1 asks us to find the area of the region between the graphs. So the first thing we're going to do is we're going to sketch the graphs. So y equals x squared is the parabola that faces up. Y equals negative x is the line. That's the negative line. And we're going from 0 to 2. So we're looking for the area of this region. So we're going to draw a vertical strip. Remember, this is my rectangle. And we're going to find the area of that rectangle. So the area is going to be the top minus the bottom. So x squared minus a negative x times the base, and the base is the small change in x. So the area of the whole region is when we sum up all of these rectangles together. So I'm going to be going from 0 to 2 of x squared plus x dx. So now taking the antiderivative of x squared, we're going to add 1. So we get x cubed over 3 plus x squared over 2, and I'm going from 0 to 2. So 2 to the third plus 2 squared, so that would be 8 third plus 4 halves, and that would be 14 thirds. So example number 2, we want to estimate the amount of pollution removed from the lake between 1995 and 2005. So notice that we are given the derivative, and the reason I know that this is the derivative because this is tons per year. So I have a rate, and the rate is the derivative. So to find the tons, I'm going to have to find the antiderivative, and it's going to be from 1995 to 2005. So I'm going to let t equals 0 be 1995, and t equals 10 be 2005. So if I find my integral, I'm going the integral from 0 to 10 of 20e to the negative 0.5 t dt. Taking the antiderivative, 20 is a constant, so I'm just going to bring it down. And the antiderivative of e to the negative half t is negative e to the half t divided by the inside. So notice that negative a half, negative 0.5 is the same thing as negative a half. So that's going to be 2. So if I substitute, and I'm going to have a negative 40e to the negative 1/2 times 10. So if simplifying even more, my final answer is going to be negative 40 1 over e to the 5th minus 1. So in number 3, they want us to find the volume, and we're given that the base of a solid is bounded by the x-axis, the y-axis, and the line x plus 2y equals to 8. They also tell us that the cross-sections perpendicular to the x-axis are semicircle. So perpendicular to the x-axis means that my vertical strips are going to be vertical instead of horizontal, and because they're semicircles, on top of this base is going to be a bunch of semicircles. So the volume is going to be the area of the cross sections, which is the area of a circle, or a half a circle. So it's going to be pi r squared divided by 2. So I need to find the radius. So remember, the radius is that yellow line. So it's the top minus the bottom. So I'm going to have to solve for y. So I get y equals 4 minus 1/2 x. So the radius, which is the top minus the bottom, is going to be 4 minus 1/2 x divided by 2, because what we found is we found the diameter of the circle, not the radius. So when you divide it by 2, so notice that 2 is the same thing as 2 over 1. So if I multiply by the reciprocal, I'm going to have the radius as 2 minus 1/4 x. So now to find the volume of this figure is we're going to add up a bunch of the areas of the semicircle. So the volume is going to be the integral of pi r squared divided by 2 in a small change in x, because they're vertical, so that would be my height. And then I need to find the upper and lower bounds. So notice that my circles are going to start at 0 and they're going to end at 8. So if I take the antiderivative, the only way I can take the antiderivative of this is I have to actually multiply them. Another way that you could have done this is by letting u be 2 minus 1/4 x. Since when you solve for du, you get 4. That'd probably be the easiest way. But I solved it by go ahead and multiplying and finding the antiderivative. And then substituting the 8 minus substituting the 0. And your answer turns out to be 16 pi over 3. So number 4, they ask us to find the area if we know that the region is bounded by the curve 2x squared plus 8 and x to the 4th. So to find the area, we're going to draw a rectangle. Okay, that's going to be my strip, and I need to find the area of the strip. So the area of the whole thing is going to be when we're summing a bunch of these strips, so it's going to be the integral. And we need to go from where to where. So if you notice, the right side of the curve and the left side of the curve are the same. They're symmetric. So instead of going from -2 to 2, we're going to go half and multiply it by 2. So we're going to go 2 times from 0 to 2. So now I need to find the length of my rectangle, and it's the top curve minus the bottom. So notice that the bottom curve is x to the 4th, and the top curve is 2x squared plus 8. So if we have the top minus the bottom. So now that I have my integral, which is the top minus the bottom, I'm going to go ahead and take the antiderivative. So remember, we're adding 1 and dividing by the new exponent. So then I'm going to substitute 2 into my equation, minus 0. So I get my area to be 448 over 15. For number 5, we're going to find the total expenditure from January 1, 1990 to January 1 of 2007 if we're given the equation as equals 4.08 e to the 0.074 t, and this is billions of dollars per year. So to get the dollars, we're going to have to find the antiderivative. So if we let t equals 0 be 1990, so t equals 17 is going to be 2007. My integral is going to be from 0 to 7. We take the antiderivative. So we should have 138.851 billions of dollars. So remember to write things in 3 decimals, because that is what the AP is going to expect. For number 6, we're trying to find the value of k if we know that the population doubles every 5 years. So the first thing we're going to do is we're going to solve the differential equation. So if you remember the differential equation, we're going to put anything that's y to the left, everything else on the right. We're going to take the antiderivative of both sides. And in this case, because we're not given an initial value, we can't solve for c. So we're going to solve for y. So we're going to take e of both sides. Okay, so notice that the c is above the e. So my differential equation solution is going to be y equals y sub 0 e to the kt, And the reason I had a c from e to the c, because plus or minus e to the c is an arbitrary constant, so I can put c, but when t is equal to 0, y is going to be y sub 0, so that's how I get y sub 0. So one of the things that you need to remember is that this formula dy dt equals to ky, the solution is always y equals y sub 0 e to the kt. So now the question was, find k if we know that the population doubles every 5 years. So when the population is 2 times y sub 0, we know t equals to 5. So if we substitute that in, we end up with 0.1386. For number 7, for part A, we're given a region and we're trying to find the area of the region. So to find the area, we're going to do a rectangle and we're going to find the area of this rectangle. So the area of the rectangle is the top, which is 2x, minus the bottom, which is x squared. And that's give me the area of one of the rectangles. So to find all of them, we're going to go ahead and take the antiderivative from 0 to 2 of my area times the small change in x. So if I take the antiderivative of 2x, that would give me 2x squared over 2. X squared would be x cubed over 3, and I'm going from 0 to 2. So the area is going to be 4 over 3. For part B, we're finding the volume of the cross-section perpendicular to the x-axis. So remember, perpendicular to the x-axis means that it's going to be vertical since it needs to be perpendicular. But one of the things that we're given is that we actually have the area. We don't know what the cross-section is, but we have the area of the cross-section. And if you remember, the volume is the area of the cross-section times the small change in x. And the reason it's a small change in x is because if you draw your vertical strip, the x is a small change in x. So my volume is going to be the area of the cross-section times the small change in x. And I'm going from 0 to 2. So if I take the antiderivative of sine, that's going to give me negative cosine times or divide by the derivative of the inside. And the derivative of the inside is pi over 2. So we're going to do the reciprocal. Okay, so now cosine of pi is going to be negative 1. And cosine of 0 is 1. So when you simplify, you should get 4 over pi. For part C, we're asked to find the volume if the cross-sections are perpendicular to the y-axis are squared. Well, perpendicular to the y-axis means that I'm going to have a horizontal strip, and they're going to be squares. So we have a bunch of squares on our base. So the volume is the area of the cross-section times a small change in y because the strips are horizontal. So we need to find the length of the square, but in order to find the length of the square, we have to write our equations in terms of y. So remember that my length is going to be the right minus the left, so that's going to be the square root of y minus 1/2 y. So my area is going to be the square root of y minus 1/2 y squared dy for my volume. Notice that I'm going from 0 to 4 this time instead of 0 to 2 because it's the y-axis. And the problem says to write but don't evaluate. Okay, so this would be in the non-calculator portion of a test. For D, they want us to find the volume if the region is revolved around the x-axis. So I'm going to go ahead and draw this again so you can see what it's going to look like if it's revolved around the x-axis. So notice if I'm revolving, I actually have this hole in the middle. So I'm going to have to use the washer method. So I'm going to have to find the area of the big disk and the area of the small disk. So big R is going to be the top minus the bottom, so it would be 2x minus 0 or 2x. Little r would be x squared minus 0 or x squared. So my volume, remember that the area of a cross section is pi r squared. It's going to be pi r big R squared minus little r squared. So if I take, and I'm going from 0 to 2, so if I take the antiderivative, I'm going to have 4x cubed over 3, substitute the 2, substitute the 0, and you should say 64 over 15 pi.